Good morning. Today is the first lecture of basic electronics. So we will start with the basic electronics, introduction of basic electronics. If we talk about nowadays, we are living in the age of information and technology, and electronics is at a very foundation of this information and computer age. This giant success we have made in this area of communication and computer is possible only because of great success that we have achieved in the field of electronics. Sometimes it is unbelievable how many electronic gadgets we are carrying nowadays, each and every person, such as wristwatches, calculators, cell phones, digital diaries, digital cameras, video cameras, etc. Even different types of electronic equipments that are involved in your office at your home nowadays. Sometimes many things we are using at home and office are remote control, such as TVs, air conditioners, audio equipments, telephones, etc. It is almost like a magic how even a small child nowadays can switch the channels or increase or decrease the volume of the sound of the TV at home just by flipping few buttons and sitting on a sofa or anywhere so far away from the television without any physical or any wired connection with the television or any other devices. So electronics have made all these things very easy to use different gadgets. Not in this area, even electronics have made deep impact in several vital areas such as healthcare, medicals, diagnostic and treatments, air and space travels, automobiles, etc. So this is so we will also discuss some history background or some brief history of the electronics also. So the invention first the invention of vacuum tubes or harmonic valves brought in the age of electronics. First invention in the field of electronics was the vacuum tube. Vacuum tubes which brought us into the field of electronics. Many new and other applications are found in these devices by using these vacuum tubes. Many great names are involved in this one. Edison's, Ambrose Fleming, De Forest, all these great scientists are associated with the field of electronics also. After the World War 1948, that is Second World War, after the World War, the transistor was invented. Transistor was invented in the Bell Laboratory. Bell Laboratory in USA. The Bell Laboratory is invented by the scientists Bardeen and Shockley. Two scientists, one more scientist is there, that is Bardeen, I think. Or Bardeen and Shockley is confirmed, one more scientist is there. That got these scientists, when they invented the transistor, they got lot of or wider applications in the field of electronics. After the invention of the transistor, many other circuit also invented. The one other circuit, by combination of these circuit of many electronics, two people have a different idea to design the integrated circuits. Circuits that is IC, that is called IC. Almost the same time when the transistor was invented, they also invented the I see some little differences there, but almost the same time. So the transistor has become a commonplace in everything, from radios to phone to computer. Now manufacturer wanted something even better. When the transistor was invented after the success of this electronics and integrated circuit, it is extensively used in each and every area. Every electronic devices you have to use it. This IC was invented by Jack Kilby. He is from Texas Instruments. He is from Jack Kilby is Texas. He is a scientist from Texas Instruments. And Robert Noyes, Jack Kilby and Robert Noyes. Both are from Jack Kilby is from Texas Instruments and Robert Noyes is from Semiconductor. And one more scientist there, that is Fairchild. Semiconductors are invented by the integrated. These three scientists they have mainly invented the integrated circuit. Integrated circuit is nothing but the multiple number of transistors, different devices, resistor, capacitor, all are fabricated on a single chip. That is called the integrated circuit, right? So integrated circuit has made up almost every modern device you found. Okay, if you open your TV, laptop, everything, that is motherboard is nothing but the complete integrated circuit. Some IC will be there, different integrated circuit will be there in a motherboard, right? So these are the basic foundation when the transistor was invented, when the integrated circuit was invented by the scientists. We will repeat these things. If we differentiate or bifurcate the basic electronics, see, that is basic electronics, if we divide, it is mainly in three parts. First one, that is component and devices. It is divided. Second one, that is measuring instrument. And third one is the circuits. The third one. Okay. In basic components, it is mainly two types. That is passive and active. Passive are mainly resistors, capacitors, inductors, diodes, etc. And actives are mainly transistors and these are all passive components. And this is transistors, op amps, etc. Lot of circuits are there, active circuits. If we talk about the passive components are basically are those circuits those cannot amplify the any signal. When you will apply any signal to the circuit, across these passive components, they will not amplify the circuit. They will attenuate the circuit. They will attenuate the signal. This signal may be voltage signal or current signal. जब भी आप कोई भी if you will apply any voltage signal or current signal, they will attenuate it. On the other side, active circuits or active component, they will basically op amp or amplifier, op amp or transistors. They are involved the enhancement of the signal. When you will apply the voltage signal or current signal, they will enhance that. Suppose you are applying with the 2 millivolt ampere, 2 millivolt peak to peak signal to the circuit. They will amplify it according to the gain of the circuit. So it may be 2 volts, it may be okay. If you will apply the 2 millivolt signal, they will amplify it. It may be 2 volt. It depends on the gain of the circuit. उस active component का gain क्या है? It will amplify. It means it will enhance the signal. It means suppose you are applying this signal something 1 volt, so output you will get something bigger, right? It will amplify, it will enhance the signal. So it, when the signal will apply to the active components, they will enhance the signal, and passive components, they will decrease the attenuate the signal. Okay. On the other side, the measuring instrument, they have a digital multimeter. Just a minute. That is digital multimeter. Power supplies, voltage source, current source, sources, function generator, oscilloscope, function generators. Okay, these are the measuring instruments where we will measure something. Digital multimeter is mainly used to measure the value of resistor, measure the voltage, how much DC voltage you have applied. Current, you can, small amount of current you can measure. Power supply to give the supply to the circuit. Voltage source, current source, these are the sources. Oscilloscope to measure the signal. To observe function generator, different type of function generate. Suppose we have to generate different type of function, we will use the function generator for generating the different signals, such as sinusoidal signal. This is sinusoidal signal. RAM signal we can generate by using the function generator, and we can see this signal, how it is signal is generating by using the oscilloscope. Okay. Next is the circuits. These are circuits basically, by circuit is nothing but by using these active and passive devices or active and passive components, we can these instruments we can design the circuits. Okay. So circuits are mainly rectifiers are there. Rectifiers, amplifiers, oscillators, filters. These are the basic. Multiple circuits are there. So just understand the basic things. Now, basic electronics is mainly divided into the three parts: component and devices, measuring instrument, and circuit. कंपोनेंट और डिवाइसेस भी उसको दो पार्ट्स में करता है, इधर पैसिव होगा, एक्टिव होगा. पैसिव, व्हाट इज पैसिव? Passive, which will attenuate the signal. When you will apply some input to the passive component, it will attenuate the signal. जो आप दोगे वो नहीं मिलेगा, right? As compared to other side, active device or component, they will enhance the signal. जो भी दोगे उसको enhance करके देगा, right? Second one is the measuring instrument. Whatever signal you have to measure, we will use these measuring instruments. These are digital multimeters, power supplies, voltage source, current source, etc. Okay. Then the circuit, by using these component and devices, we are defining different circuits. Rectifier, if we talk about the rectifier, using the diode, single diode from resistor across connect करके हम लोग rectifier बना सकते हैं. We can design the amplifier, oscillators, filters, anything. Lot of circuits are there, etc. Multiple. Okay, these are the basics of the electronics. So before going to the deep into the electronics, we should understand the basics of the electronics. What is that? Now, so basic that everything we talk about the current and voltage. So what is that? इसमें होता क्या है? What is the electronics? So we should, in any semiconductor, if we go to the electronics, we must know what is semiconductor, right? A semiconductor, to understand the semiconductor, we should know the different conductors, insulators, and semiconductors. Okay, so I will just, we have designed something. Okay, so see this. Normally we have three types of devices. Mm, that is metals, insulators, and semiconductor. Here I have designed the two thing, that is metal or insulator. Okay, so before going to that, I have seen this. See, this is a metal, CV, this, and VV. This CV is nothing but the conduction bond. This is not CV, this is CV. Okay, and this VB is nothing but the valence band. Okay, the full form of this CV and CV. If we talk about the metals, metals are fully conductors. Conductors means they will conduct the current. Conductor is a basic material that easily conducts electrical current. Okay, the best conductors, if you talk about the, that is कोई भी single element material such as copper, it may be, silver, it may be, gold, it may be, aluminum, it may be, right? These are the fully conductors. They will carry the currents. Okay. Why these are carrying? Because these atoms have a characteristics. They have only one valence electron, that is very loose bound to the atom. Right? These loosely bound valence electrons can easily be break away and from their atoms and become free electrons. क्योंकि जो metals होते हैं इसमें क्या एक single electron lose होता है last उसमें, तो उसको we can easily break it and that electron can make a conduct to conduct. Okay. So as compared to the other side, that is insulator. Insulator, it also have a valence band and conduction band. The basic difference is that, see, this is one, I think I have written here, that is EG. See this. That is energy gap. This is the gap between the valence and conduction band. Okay. So this gap is called the energy gap. Normally it is for insulators. Insulator is nothing but your wood. There is no current across the wood, right? This energy gap is from 5 electron to 15 electron volt. That is very large, right? So if we talking about the zero conduction, zero Kelvin, this K is the nothing but the Kelvin. We are talking about the temperature. Normally at zero temperature, when we are taking the conduction, metal will conduct. They will there will be flow of electron, so the current will flow. But in an insulator, there is no flow of electrons, so no current will be there. But when the conduction, when we will raise the temperature at room temperature, किसी insulator या उसी को room temperature पे ले आओ, what will happen? The insulator will be as it is. There is no conduction will be there, but you can see in this figure here the conduction band and valence band will be overlapped in the metal, right? In metals at 0 Kelvin, no energy gap is there for a metal because they are already in a conduction state, right? But we will raise the temperature, they will overlap, or jitna, how much temperature we will raise, this overlapping will be increased. This is for the metals. So we can say metals are the conductors. They can easily conduct at normal 0 Kelvin as well as 30 Kelvin, 300 Kelvin also. But insulator, they are bad conductors. They are not going to flow any current. They have a large energy gap. That is energy gap. Now we talk about this energy gap also. Just I will define you. So, as I told, all of you have read in your 12th the electron valence shells are there in a atom stage. Suppose if we talk about the germanium and silicon, germanium has atomic number 32 and silicon has I think 14. So how many cells are there? 3 or 4 cells are there, and each cell 2, 18, 8, something like that. Okay. So this is the same phenomena here also. This Eg is the difference in the energy between the valence and conduction band. It is called the energy gap. The difference between this valence band and conduction band, right? The difference in energy, yeah. At this point, this valence band point, we have a different energy, and this conduction point, we have a different energy, right? So this gap, the difference in energy between the valence and the conduction band is called the energy gap. Okay, this is the amount. ये होता क्या है? This is the amount of energy that the valence electron. ये valence band में क्या valence electron रहते हैं? So this is the amount of energy that valence electron must have, right? This, okay, this is the amount of energy that valence electron must have in order to jump from valence band to conduction band. ये एनर्जी क्या होगा? जो वैलेंस इलेक्ट्रॉन इस वैलेंस बैंड में है, अगर यहाँ का इलेक्ट्रॉन यहाँ पे जंप करता है कंडक्शन बैंड पे जाना, तो उसके पास इस गैप के अकॉर्डिंगली एनर्जी होनी चाहिए. इट शुड हैव द difference between the conduction band and valence band energy, then it can move from valence band to conduction band. Okay. Once in the conduction band, the electron is when this electron or free electron will move to the conduction band, right? They can easily move throughout the material and they will flow the current. All these things. One other semiconductor. These are the about the metal and insulator. Next, I have just a minute. Okay, this is for the semiconductor. I will show you something here. This is for the semiconductor. Now, this is the conduction band, right? This is the conduction band, and this is the valence band. Okay. So this is the conduction band, valence band. In semiconductor, Eg is 1 approximate something 1.21 electron at 0 Kelvin, but I have written it 1 electron volt. This is okay. Normally at 0 Kelvin, that is 1.21 electron volt is there. This energy gap Eg. But normally lot of books you will get 1 electron volt will be there. Okay. At 0 Kelvin, the gap between the conduction band and valence band is 1 electron volt. Okay. And there is a no conduction when at 0 Kelvin. कोई कंडक्शन नहीं होगा. No free electron from valence band will move to the conduction band. So we can say that at 0 Kelvin the charge carriers are 0 and there is a conductivity will be 0 for the semiconductor. So we can say that at 0 Kelvin semiconductors are insulators. Okay, at 0 Kelvin semiconductors are insulated. Okay, means जब कोई करंट नहीं फ्लो हो रहा है तो it will be insulated. But now see the different case when put this semiconductor at room temperature. What will happen? So the bond will be breaks, right? So electron will get the sufficient energy from valence band. भाई टेम्परेचर बढ़ेगा तो जो ये इलेक्ट्रॉन जो होते बॉन्ड से किस बॉन्ड से बने होंगे, एक एटम जो किस बॉन्ड से, दे विल बी ब्रेक. द ब्रेक हो गए इलेक्ट्रॉन होल पेयर जनरेट होगा. सो जो वैलेंस बैंड में इलेक्ट्रॉन थे दे विल मूव टू द कंडक्शन बैंड. दे विल गेट द सफिशिएंट एनर्जी. जो इलेक्ट्रॉन वोल्ट 1 इलेक्ट्रॉन वोल्ट की रिक्वायरमेंट थी वो सफिशिएंट एनर्जी मिल जाएगी. They will move to the conduction band and current will be flow. They are freely moved in the conduction band, current will be flow. Now, I have written here the holes and here is the electrons. What is that? when the electron will move from valence band to conduction band, absence will be there. Electrons ka absence, hole is nothing but the absence of the electron. Okay, so that's why I have written here electron hole, and this is the free electron. This is called the free electron. Alright, at 300 Kelvin. Now this will become conductor. So we can say that the conclusion of this, at 0 Kelvin, the semiconductor are insulators, but at room temperature or higher than, they will become a conductor. They will conduct. There will be flow of electron as well as the current also, right? Now you see all these things. I have written something. This is Eg, that is Eg is nothing but the energy gap at 0 Kelvin, Eg at 300 Kelvin. This is normal. You can remember all these things. This is for the silicon semiconductor, germanium or gallium arsenide. Okay. Normally we use the three types of in devices. We will use the silicon. Mainly we will use the silicon or germanium. Germanium arsenide is the normally because it's a combination of two materials. Okay. So normal, okay, when we will combine two materials, it is not possible to work at 0 degree because they will not combine until we will not heat it or we will give some external force to it. Okay, that's why the energy gap at 0 is nothing. For energy gap for germanium arsenide at Eg300 is 1.47 electron volt, and germanium Eg0 for silicon is 1.21 electron volt. Eg for germanium it is 0.785 electron volt, and for at room temperature it is 1.1 electron volt and 0.72 electron volt. This is the basic things for conductor, insulator and semiconductor. In the previous slide I have just given, see that the energy gap, how far energy gap is there. In this case, how far this gap, this Eg, this is nothing but the Eg. See, the small gap is there. It is almost 5 to 15 electron volt. This is 1.21 electron volt, and there is a no gap. It is already overlapping. Whatever I have told to you. This is the energy diagram for insulators, semiconductor, and conductors. Is it okay? Now we should move on. Every time we are I will write it here. Every time we are talking about the electron volt. What is electron volt, right? So it should be known to you. Electron volt is nothing but the unit of energy. I think all of you know, but just I am telling you. It is unit of energy. How it is unit? It means why it is 1 electron or electron volt. It means, just listen it. 1 electron volt is defined as the energy gained by the electron in mainly through a potential difference of 1 volt. Means 1 volt का potential difference apply करने के बाद जो energy gain करेगा electron, that is called the 1 electron volt. Okay. Alright. So this is the definition of, if you say I can write it, so do that. Just I will. 1 electron volt is defined as the energy gained by the electron in moving through a potential difference of 1 volt. Okay, this is the definition of 1 electron volt. Alright, so we will move on. So we have done the insulators, semiconductor and conductors. Right, now we will talk about some I have already told we are mainly using the germanium and silicon. Okay, so we should know all these electrons diagram, how many cells are there in germanium and silicon atoms. Okay, now here you can see that this is for the silicon and this is for the germanium. As it is, I told it is atomic number is 14, so you can say it has a 14 electrons, 2, 8, 10 or 4, 14. And most important is that in the outer shell they have a 4 valence electron. Okay. Now, one question it will get arises here. Why this gap? Just for silicon it is 1.21 electron volt and it is for 0.785 electron volt. Why? This gap is there at 0 Kelvin or something. So this will be answered in this diagram also. Now, see, this is the atomic structure of silicon and germanium, right? Silicon is most widely used material for designing any diode, transistor or ICs. Lot of reasons are there, but it is mainly used. Okay. For any other semiconductor devices, we are using a silicon. Okay. Now see the both silicon and germanium have their 4 valency electrons at outer shell. Okay. All are same almost. They have a 4 valency electrons at the outer shell, right? These valence electron in germanium are in fourth cell. Why it is fourth cell? This is first cell, this is second cell, this is third cell, fourth cell. I am giving the answer why it is Eg energy gap is 1.21 for silicon and 0.785 for germanium. Okay. Now see the valency electron in germanium are in the fourth cell, right? While for a silicon they are in the third cell. 1, 2, 3. This is first cell, this is second cell, this is third cell, and this is first cell, this is second cell, this is third cell, this is fourth cell. Okay. So you can see that the silicon have a valency electron. They are 4 at the outer cell. They are much closer to the nucleus. This is suppose if it is a nucleus, it is a much closer, right? This means that the germanium valence electron at हायर एनर्जी लेवल, भाई कौन से चौथी लेवल पे है ना, दे आर एट फोर्थ लेवल इन जर्मेनियम. सो जर्मेनियम वैलेंसी इलेक्ट्रॉन्स आर एट हायर एनर्जी लेवल देन सिलिकॉन. ओके, देयरफॉर रिक्वायर अ स्मॉल अमाउंट ऑफ एडिशनल एनर्जी टू एस्केप फ्रॉम द एटम. भाई ये हायर लेवल पे है, हायर लेवल पे है तो वीक होंगे. भाई जो न्यूक्लियस के पास रहेगा दे विल बी अटैच विद द मूव पावर, right? So they are much far better than the nucleus. So they require less energy to extract from this nucleus, right? Detach करने के लिए less power के require. That's why the Eg have 0.785 electron volt at 0 Kelvin. Not this Eg. Okay, and they are closer to the nucleus. That's why they need higher power, that is 1.21 electron volt at 0 Kelvin. Okay, this is the reason. Okay, is it clear? Now this is for the silicon and germanium. Now we will move to the next, bonds. Right, what is bonds? Bonds means when you are using any material, any device is a combination of multiple materials. कोई भी होगा तो उसको multiple कई सारे होंगे. They will be attached with some bonds, right? When these atoms are combined to form a solid, भाई सिलिकॉन का एक छोटा सा पार्टिकल है, उसको कंबाइन करके ही तो एक बड़ा सा बनाएंगे. So when the atoms are combined to form a solid crystalline material, they arrange themselves in a symmetric pattern. When we have to combine this, we have to arrange in a symmetric pattern also, right? The atoms within the crystal are held together by covalent bond. Okay, so जो स्ट्रक्चर में जो एक दूसरे को बॉन्ड बनाएंगे, जो ऐड करेंगे एटम्स में, दिस इज कॉल्ड द कोवैलेंट बॉन्ड. ओके, which are created by interaction of valence electron. जो ये एक्सटर्नल वैलेंस इलेक्ट्रॉन है, these Previously I told silicon has a 4 valence electron. इनको attach करके बनाएंगे. Alright. So these covalent bonds are created by interaction of valence electron of the atoms. Right? So we can say this is a covalent. This is the atoms where the bonds होगा, that is called the covalent bond. Alright. Now see this here. See here. Now see, first see this one. We have a one silicon atom, second silicon atom, third silicon atom, fourth, fifth. 5 silicon atoms are there. Right? We are going to attach, and we know that each silicon have 4 वैलेंस इलेक्ट्रॉन एट द आउटर सेल. राइट? अगर इसको किसी दूसरे सिलिकॉन के साथ अटैच करोगे तो ये 4 ये वैलेंस इलेक्ट्रॉन आपस में कंबाइन, दे विल मेक अ कोवैलेंट बॉन्ड. इन द सेम थिंग इज देयर. दिस इज 1 2, सपोज दिस इज 1 वैलेंस इलेक्ट्रॉन, सेकेंड वैलेंस इलेक्ट्रॉन, थर्ड वैलेंस इलेक्ट्रॉन, फोर्थ वैलेंस इलेक्ट्रॉन. इन द सेम वे इट हैज अ 1 इलेक्ट्रॉन, 2 3 4. This is 1, this is 2, this is 3, this is 4. This is 1, this is 2, this is 3, this is 4. Right? So these 4 or iska third, they will combine in this way, or I can just decide here. See this one. This is, suppose this is 1 2 3 4. Right? See, this is, suppose this is the atom. It has a one valence electron, 2 valence electron, 3 valence electron, 4. Similarly, it has a 1, it has a 2, it has a 3, it has a 4. So they will combine and make a covalent bond. In the same way, they will make a covalent bond with the and form a crystal. Okay, right? So these are the covalent bonds. Also, we should know one thing. This sharing of valence electron, right? जो ये शेयर हो रहा है वैलेंस इलेक्ट्रॉन का, प्रोड्यूस अ कोवैलेंट बॉन्ड. एक कोवैलेंट बॉन्ड तो बनेगा. दैट विल होल्ड द एटम टुगेदर, एक दूसरे को कंबाइन करके रखेगा. राइट? ईच वैलेंस इलेक्ट्रॉन इज एट इक्वली, ईच वैलेंस इलेक्ट्रॉन विल बी attached equally by adjacent atom. Right? And they will share with each other. Right? So this covalent bonding is normally in intrinsic silicon crystal. Okay, so this is the intrinsic. If we see the next figure, I will tell you this is nothing but the covalent bond in silicon crystal. You can see this is a complete silicon crystal. Multiple silicon atoms are there. They all have a 4 valence electron. They are attaching, they are making the covalent bond with the same nehavar atoms. Okay, each have a, because they have a, all have a 4 valence electron. Right? They will combine with each other. Okay, this is a covalent bond in silicon and crystal. Now, so till now we have discussed about the insulators, conductors and semiconductors, and how we are making the bonds. Right? When we have a germanium, in the same way we can decide for the germanium also, because it also has a 4 valence electron at the outer shell. The same way we can do that. If we say it is germanium, it also have a 4 valence electron. In the same way, if you take the put your germanium, it is same thing. Okay, but germanium has some disadvantages. So that's why normally we are using most advantage. Why we are using silicon? Because it has a leakage current very small. In small in silicon, right? Silicon में it is in nano ampere. It is in germanium it is micro ampere. It is too high. Okay, जो लीकेज करंट, अनवांटेड करंट जो होती है लीकेज करंट, we will discuss in the further lectures. Just for your information, why we are mainly using the silicon crystal every time. Okay, so this is for the bonding in silicon and germanium. Okay, now the conduction of electrons, how the conduction will be flow, how the current will be flow. Okay, In this figure, I have given you the two energy diagram and bonding diagram. See, every time we are talking about, right now we are talking about the pure silicon. Pure silicon means intrinsic. It has a number of electrons and holes, equal number of electrons. Then it is intrinsic. Okay. If in any intrinsic silicon crystal at room temperature, अगर किसी भी semiconductor या silicon के उसको room temperature पे when you will put in a room temperature, right? Room temperature have a sufficient heat to energize some valence electron. See, this is suppose it is a complete silicon atom. Okay, this is complete silicon atom. It is a valence band. See, this is a valence band. This is a conduction band. When we will apply the heat, when we will heat up at room temperature or higher, okay, some of the electrons will move from conduction band, valence band to conduction band. See this one? When they will move, they will the electron we have before applying the heat, we have an electron in valence band. Okay, but when we apply the heat, the electron will become free. They will get sufficient energy to cross this energy gap. This energy gap, they will, when we will heat this material, they will get the sufficient energy to cross this gap. They will move from valence band to conduction band. The deficiency of the electron is nothing but the holes in a valence band. Okay, now when we heat up, the electron will move from conduction band to valence band. Okay, and when it will reach the conduction band, they will become free, and free electron is called the conduction electron, right? When this is the electron, this is called the conduction electron. That is, free electron is nothing but the conduction electron. Okay, all right. When these electrons jump to the conduction band, a vacancy is left in a valence band. See this. When this initially this electron is here, suppose it will move to the conduction band. One vacancy is left in a valence band. Okay, within the crystal. This vacancy is called nothing but the hole. Okay, so for every raised electron, which will move from valence band to conduction band, there will be one vacancy, right? There will be one vacancy in a valence band also. Okay, so for every electron raised to the conduction band, by applying some external energy, here external energy is heat. Okay, there will be one hole left in a valence band. Okay, so this is called the creating, or that is called the, what is called the इलेक्ट्रॉन होल पेयर, राइट? तो यहाँ पे क्या था, एक कुछ था वैलेंस बैंड में, उसको हिट किया तो फ्री इलेक्ट्रॉन मूव हो गए, वैलेंस छूट गया. दिस इज नथिंग बट द फ्री इलेक्ट्रॉन होल पेयर. इलेक्ट्रॉन होल पेयर था, राइट? व्हेन रिकॉम्बिनेशन विल डन, कहीं पे आफ्टर sometimes it will be when these free electron don't have sufficient energy to stay in a conduction band, they will come back to the valence band, they will again combine with these holes. Okay, that process is called the recombination. Again hole और free electron combine होगा, this is called the recombination. Okay, so this is called the recombination occurs. Recombination occurs when conduction band electron loses energy back and fall into the valence band. Okay, this is the basic definition of what is free electron and what is the hole. Now, how this current will be flow? Okay, for that we will move to the next one. See this, or we can see in the same way also. See, when wave heat, sometimes it is heat, or sometimes we will apply some external potential also. Okay, see, this is the basic. Here you can see initially it is all are they all are combined with the valence covalent bond, but when we are applying the heat energy or potential something, the free electron will be detached, they will left with the hole, right? This is the electron hole pair in a crystal. Okay, free electron will move to the conduction band, and hole will be in the valence band. Okay, but sometime when these electron or free electrons will lose their energy, they will again come and combine with the hole. Okay, this is the generation of an electron hole pair and recombination PEC. This is the generation of electron hole pair. This is the generation, and when again it will lose the energy from conduction band and come to the combine with the electron hole in a valence band, this is called the recombination. Okay, so this is the electron hole pair generation and recombination. Now, how the current will flow? See, how the current will flow in electrons. See, suppose we have a silicon crystal, multiple crystal, they are attached with the covalent bond. When we will externally applied plus minus दिया, कोई भी supply will apply some supply or voltage is there. Okay. So when we will apply the potential, thermally generated free electrons in a conduction band. जब हम when we will apply this potential, the electron will be detached from hole to यहाँ से जो electron hole pair था detach हो जाएगा, free electron will move to the conduction band, right? And it will be freely moved. So freely move करके क्या होगा? So they will freely move in a crystal. Now when we are applying the potential negative and positive, and we know that free electron have a negative charge, so this positive supply will attract, right, towards the positive end. Okay, so this movement, so we can say these all free electron is moving towards the positive terminal. Okay, this movement of free electrons is one type of current in a semiconducting material, and it is called electron current. Okay, now again if we talk about the hole current. Okay, now see this is the electron current. When electron will be free, they are free to move in a crystal, and if we apply the potential, the electrons are negative charge, they will attract towards the positive and the current will be flow. Okay, now see the hole current also. Now this hole current is nothing but these holes are nothing but created by the free electrons. Okay, so the electrons remaining in a valence band, that is all called holes, right? They are still attached with the atom. भाई जब इलेक्ट्रॉन था यहाँ पे, just I will just minute. ये CB हो गया, this is PB. So when electron is there, it will move to the conduction band, it will left the hole. Okay, right? Right, it will left the hole, but this hole is not free to move because it will attach with the crystal, right? ऐसा नहीं, as it is electron here, this electron it is free to move, but in the valence band this hole is attached with the crystal, they are not allowed to move freely, right? However, this valence electron, that is nothing but the hole, can move into a nearby hole. See this one. Suppose ये पूरा valence band है. Suppose this is complete valence band is there, right? So we can move the nearby, right? Valence electron can move into a nearby hole with little change in energy level from. Okay, so it will change the position from one hole to other hole. This movement of hole, we can say it is moving from one place to other place, right? Effectively it is changing the energy also. or we can see that it is moving from one place to other place, right? In a crystal structure, this is nothing but the called hole current. Okay. Now you can see this one. Initially it is electron is detached here, valence electron, hole is generated. Again, some valence electron came. It will move this combined. Valence electron is there. Okay. See, just let me little bit clear from this figure. Okay. See, one hole is there. This one extra electron came from somewhere from conduction band, loses energy, come and combine with this hole, or some electron is there, some this energy, this level have some electron also. Suppose it gets some energy, electron will detach, it will combine with this hole, and this is left with the hole. Another one, same electron from other point, they will lose their energy, they will attach with the, they will break the covalent bond, they will attach with this hole, so this hole is left. So this complete chain will be processed. This, from this point of view, we can say hole is nothing but the moving from one place to other place, right? Okay, so it is nothing but called the hole current. All right. So we will stop it here up to this current conduction. From next lecture we will discuss about the intrinsic semiconductors by using this silicon. Extrinsic semiconductors, when we will add some doping in an intrinsic semiconductor, there will be different type of semiconductors. N-type, extrinsic are mainly N-type semiconductor or P-type semiconductor. Before going to these intrinsic and extrinsic semiconductor, we will also see some basic term, conductivity, what is conductivity, for formula for that, how we will measure the conductivity, or what is the resistivity, all these things, these are important parameters to understand the um, uh, uh, intrinsic and extrinsic semiconductors. Okay, that's it for today. We will move on. We will meet on next lecture. Thank you very much.